Square ABCD has area 36. When you read this far, you already know something. What's that? This square has side of 6 and 6. So it would look something like this. But how do you know it's this shape that is not this? It could be this, no? So what's there to say that we have a square that is sitting nicely like this? That's why we got to wonder. Then it actually gave you the clue. It says an AB is parallel to the x-axis. So we can safely say the AB, whichever side, could be this, right, is parallel to the x-axis. So at least we know this is not turned around. It's not a tilted. It's not a tilted square. Okay. Vertices AB and C are on the graphs of y equals log x base A, 2 log x base A, and y equals 3 log x base A. Whoa. What is this? Do you know what the log graphs look like? If you don't, you cannot do this problem. So I would like to show you what the log graph looks like. You should know this, right? No matter what the base is, this log graphs, if it's not shifted, if it's not translated, it always goes through this 1, 0 point. The reason is anything to the 0th power is 1. That is anything to the, when y is 0, x is 1, so therefore it will go through this. So I don't know what A is, but I will just take a rough shot at it because I need to have something to go by. So that's what it is. What about the second one? Second one is the same guy except it's twice as high, so no matter where you go, you will make them twice as high. For example, here height is 2, so I will make it 4. Of course, the very first one I drew is my guess here, so everything else is just following. So in a way, it's meaningless. The only thing meaningful here is that the third graph will be 3 times as high at every point. I can see that I made a mistake already. This is not twice as high. Should have been higher. And third one will be even higher, and you know it's going to go through this. Okay, what do they want here? They are saying the vertices of the square are on the graphs. So it would be something like that. This vertex has to be here, vertex has to be here, this vertex has to be there. But you realize, there's a problem with the way we did it. It's respectively. That is, the first graph has to go to vertex A. First graph is going to vertex B here. So how do we fix that? No problem. Erase it and make it A. Boy, it's simple. And then what about this A? Make it B. Now, which one is C? Now, do I name this C and let this graph go through here? No. ABCD of a square or any polygon, you got to go in the counterclock or clockwise direction. You cannot skip around. So C has to be here. That means we want this graph to rise higher and pass through C. How do you raise a graph? Well, you do that by changing A here. I told you I drew this without knowing what A is. So it's my guess here. So obviously the guess had to be higher. I missed it. It was too low. But, when you raise this and make it go through C, wouldn't it miss these 2 points? Because everything else would rise together? You are right.